Welcome back to our in-depth Docker course. This lesson focus is on Docker's networking capabilities, a cornerstone for managing your containers effectively. Let's dive in. Docker provides various network modes such as bridge, host, and none to cater to different networking needs of containers. In bridge mode, Docker uses a virtual bridge to facilitate communication between containers and the host. The host mode directly uses the host's network, while none isolates the container from external networks. To demonstrate inter-container communication, let's start two containers on the default bridge network and use their names for communication. So what I will do here is that I will run two containers in detached mode, then I will ping one container from the other one. So let's start by running the two containers. So let's type docker run -dit, then --name container 1, then alpine ash. Now we have our first container. I will run the second container from the same image, so I will just replace 1 to be 2 and press enter. Now we have two running containers. To validate our work, I will execute docker ps, and here we have container 1 and container 2. Now let's execute ping command from container 1 to ping container 2, and let's see the result. As I mentioned before, to execute a command inside a running container, we will use docker exec, then -it, container 1, then ping the command I want to execute, then container 2. Now press enter, and as you can see, I'm getting a response from the ping command. So this works because Docker's DNS server resolves container names to IP addresses within the network. Now let's create a custom bridge network for better isolation and functionality. But first, let me force remove the container 1 and container 2. So if you added the -f to the rm command, you don't need to put the container in the stop state first before deleting it, because by adding -f, it will force deleting the running containers. So let's delete container 1 and container 2. Now let's create a custom bridge network by executing docker network, then create, and my custom bridge network will be my -network. Now let's run containers attached to the custom network. So I will execute docker run -dit -name custom1, then I will attach it to the bridge network I just created with -network my network, then the image alpine. Now press enter, and let's execute the command one more time, but this time I will run the custom2 container. Now let's ping from custom1 to custom2 containers. So I will type docker exec -it, then custom1 ping custom2. Now press enter, and as you can see, I'm getting a response from the ping command. Custom networks like this offer enhanced networking features such as static IP assignment. Finally, let's talk about port mapping, essential for making containerized applications accessible. So let's run a container with a web server mapping host port 8080 to container port 80. To do so, let's type docker run -d, then -p for the port forwarding, then 8080, and we will forward that to port 80. Now press enter, and of course I got an error message because I didn't provide the image. So I will create this container from the Nginx image. Now press enter, and we have a running container. Now the Nginx server inside the container is accessible via port 8080 on the host. Let's verify that. So let me bring here the web browser and let's type localhost 8080. And as you can see, I can browse the default Nginx page. So we have covered Docker's networking capabilities, from the basics of inter-container communication to creating custom networks and port mapping. Dive into these concepts, experiment, and see how they can streamline your container management. Thank you for joining this lesson. Looking forward to our next lesson into Docker.